Hey everybody, Miss Barry here. We're going to be talking about the second half, I guess, of this particular checklist. Two-step equations is still what we're talking about, but I want to focus on word problems that would come from that. Word problems, certainly something that we experience here throughout the class, so we want to make sure that we get a vibe for what we're kind of looking for. I'm not going to actually do any math work in this problem. What I'm going to do is kind of just show you what I like to go look at when it comes to a word problem and maybe highlighting certain aspects of the word problem. So start off obviously with reading it. A cookie jar starts off with 32 cookies in it, and each day 2 cookies are eaten. After a certain number of days, there are 14 cookies left in the jar. Which of the following equations represents the day B when there are 14 cookies in the jar? So a lot to unpack there, a couple sentences. Go back to the top. Cookie jar starts off with 32 cookies in it. And from the directions below, it says do all of the following for example 1. First thing it says is to circle all of the numbers in the problem. So, it's obviously a math class, so the numbers to us here are important. And they could potentially lead us to understanding what certain things mean in the problem. I guess we have the 14 down there. Um, Great thought. That's kind of something that's not really that is mentioned too often here. Maybe using different colors to do all this stuff. It says underline in the problem when it mentions the unknown. All right, so we're trying to figure out here where the variable's kind of at. If it does give us the variable in the problem, and it does at the end in the question sentence, which of the following equations represents the day D when there are 14 cookies in the jar? So we don't know what that amount of days are, but we do know that if we were to actually solve this equation, we'd be dealing with the variable D, so we'd be looking for something that says D is equal to something. Wouldn't be a terrible idea to underline maybe the word day, since day D is what we're going to be searching for in this equation. Might not be a terrible idea to underline that word a couple different times. It does say highlight the phrase each day 2 cookies are eat. Well, that's not right. Are eaten. So I want to highlight this. Maybe I'll just box it here for time's sake. And I highlight this, and I want to make specific note to the word each. We're aware that in math, especially in algebra, that we have certain rate words. Each, every, per, per, not like, purr, like a cat would say. Those words are words that usually let us know that is where the variable is going to be located. So we know that we have multiple terms in our equations. Terms that involve variables usually involve, in these problems, phrases such as each, every, per. Those are keywords to look for, and here we see the phrasing each. Finally, it says how many cookies were eaten total during this problem. Well, we have some numbers here, and it's not a terrible thing in these problems to figure out. Do we have a starting location? Do we have a finish location? It does say here starts off with 32 cookies, so it might not be a bad idea to note that 32 cookies is where I'm starting, and at the end of the problem, which of the following equations represents the day D when there are 14 cookies in the jar? 14 cookies left in the jar. It says the number 14 twice. That's where we're finishing this problem at. We can 100% use that to help us in these problems. So again, I'm not necessarily going to solve this problem. If you're wondering, I'll write this down somewhere. We start with 32 cookies. Each day 2 cookies are eaten. Eaten is actually a subtraction word here. Right, we're removing 2 cookies each time. Technically, you might be putting them in your stomach, but you get the point. We're removing from the pile the 2 cookies. So we're subtracting away 2 cookies, big word here, each day. So we know that that word each is meaning it's going to be a term with a variable in it. And we want to figure out how many days it would be until we get to 14 cookies. That's the